I think we completed 2 questions, and today's question is the third one, which is capital F equals to the square root of 5. This is my father's lathe. It was working. It's annoying. We can see that solution. We can see that this function is just a square root function, and according to the 3 lectures of concepts and skills, we can find the domain of this function by constructing the expression inside the square root to be greater than or equal 0. So 5x greater than or equal, I will move the plus 10 to this side to be minus 10, and I'm going to divide this inequality by 5. Divided by 5, the result will be 5x divided by 5 greater than minus 10 divided by 5. So x will be greater than or equal minus 2. So the domain of the function, let me call it y of x, it doesn't matter, so I'm going to call it capital Y as they did in the exercise in the book. So will be all x in the real line such that x should be greater than or equal minus 2. Okay, we found the domain to this function. Now we're going to move to find the range of this function. And to find the range of this function, we need to change the expression first. We need to write this function in terms of y's instead of x's. So I'm going to put y equal to, I'm going to change this to y 5x plus 10, and we need now, okay, that will cost me a lot of space, but it's okay. We need sacrifice. So to find this, I'm going to rewrite it here just to make things clear. 5x plus 10. I'm going to apply the square. So I'm going to square this. The result will be 5x plus 10. Okay. And it's just a matter of observation, as I told you. So I'm going to make it easy here. So I'm going to keep 5x in its side and y squared in its side, and I'm going to move the 10 to be minus 10, and I can divide now by 5 too. The result will be x equal to y squared minus 10 on 5. So what can we understand from this? We can understand that this expression is always, so initially we can understand that this is a polynomial. It's clear that this is a polynomial because if I want to write it in another way, I can put 105 as a common here and y squared minus 10, which is a polynomial. So initially, or temporarily, for now, the domain of the function x will be R, because this one, it should be because this is a polynomial. It's clear, but I have some restrictions. How? That means the range of the original function f will be R. That means the range or the output of the original function, which is this, will be all the real line. And that's wrong. Why? Because I have a square root and I know the output of the square root cannot be a negative. And I found the range of the function f is r, which means the positive and 0 and negative. And this is wrong. So how can I solve this problem? You can solve this problem by small notes. I'm not going here deep. We have a certain expressions here. We have a certain thing. Okay, let me tell you this path. And I want you just to understand. So as soon as we have x equal to y squared minus 10 on 5, and we have a constructions, or we have a condition for x, I'm going to put this condition, which is x greater than or equal minus 1. So I'm going to put this x, and this is equal to x. So I'm going to put it greater than or equal to minus 1. So y squared should be greater than minus 10 on I'm going to multiply by 5. Okay, let me see. I will delete this. I don't need it for now because it's already x greater than or equal minus 2. I'm going to write this one here. I'm going to divide by 5 both sides. So the result will be y squared minus 10 greater than or equal minus 10. So y squared greater than or equal 0. Okay? And if we square both sides, I'm going to find the result will be greater than 0. And this will be greater than or equal 0. And from the notations, if we have the absolute value to y greater than or equal 0, the result will be from the properties of the absolute value. Y is greater than or equal 0, or y is less than, okay, or equal 0. Okay. So you need to just understand this, that means y could be positive and 0 and could be negative and 0. This is the approach that we can follow, and we have another approach we can follow. So this approach is just the continuation of this one, but we have a simple notation that we can take, which is a short path to the answer. As soon as you find that the function is a square root, the range of that function will be always will be the positive real line. So I can here tell that I'm not gonna use this. Why? Because this has restrictions. Because when I followed this polynomial, I found that the range could be two sets. It could be y greater than or equal 0, or could be y less than or equal 0. So according to the reality of the square root cannot produce negative numbers, so it would be the positive numbers. So I can now choose the set which is range of the function f is all the y or belongs to the real line such that y greater than or equal 0. Okay? But I'm going to give you a notation. Note. In the next examples, I don't want you to follow all these steps. I want you to observe if the function is a square root, so the domain of the function always the positive r. Y belongs to the to the real line such that y greater than or equal 0, because the square root cannot produce negative numbers. So you can just omit all these steps, which is the inside and the soul of this notation. I wrote all these steps just to tell you from where we get this notation, because if we solved and applied the construction of the domain to the reality of the range and solved, and we will get two sets, and then we come back to our observation and to our intuitivity, and then we can choose that the range of this function will be just the positive numbers. So I'm going to erase this just to save the board, and you can just record these notations before I erase it in the video. So we can say now the range of the function y equal to all y belongs to the real line, okay, such that y is greater than or equal 0. This is how I am. I can't just write notations without explaining and without telling you from where I get that notation. Just to let you know, the domain and range, sometimes it gets so challenging and cannot be found by these simple steps. But according to the syllables of the calculus, you can just use it and get the full mark from these notations, or use it by these notations. So question number 4. I'm seeing the time. Yeah, question number 4. G of x equals to no, it could be, it could not appear, x squared minus 3x. So this is the square root. This is the square root of the function. It's a very challenging question. I love such kind of a questions. Solve. The domain of, as we know that the domain of the square root functions, it's all the numbers that makes the expression inside the square root greater than or equal 0. So here I need to find the value of x, or I need to find the interval that x belongs to. To solve this equation, I assume that you're familiar with the properties of the absolute value, and if I get expression with x or with the variable with exponent 2 and other variable with exponent 1, I assume that you know how to change it to the complete square. So I'm going to complete square here, but I'm going to make a small revise, a short revise to you, so I can make sure that you follow with me. If we have an expression like, for example, y squared plus a plus or could minus, it's not a problem, y. I need to make it a complete square, y to make it a bracket on square on it. To apply the square root, so I'm trying to reach this result for a purpose, to make it ready to apply the square root on it. So I need to divide this coefficient by 2, and then I need to square the expression. And I need y squared plus minus ay, and I need to add this expression squared. The result from this will be y plus minus a on 2 squared. That's called the completion of the square root. The completion of the complete square. It's called the complete square. So I will take the 3 or minus the 3 and divide it by 2 and then square the result. I will get 9 on 4. So I need to add 9 divided by 4 to both sides. So x squared minus 3x plus 9 divided by 4 greater than 9 divided by 4. I have to add the same value or the same number to the both sides to not violate the generality. I don't change this expression. I have a true statement. To produce another true statement, I have to add or subtract unequal values. So what I'm going to get from the left expression, left side, I'm going to get x minus the square root of this, which is 3 on 4, 3 on 2, squared. If you want to make sure, square this one, x squared, 2 by x multiplied by x multiplied by 3 on 2 will be minus 3x, and this term is squared will be 9 on 4. This is a greater than or equal 9 divided by 4. So I'm going now to apply the square root. When I apply the square root to this value, x greater than, I'm going to apply the square root to this value, that will be a 3 divided by 2. The result will be here, it's a squared term with a square root on it. The result will be x minus 3 on 2 greater than or equal 3 by 2. So that's why I needed to make this expression squared, to apply the square root on it, and the result will be an absolute value. And we all know that we are familiar with I assume that you're familiar with the properties of the absolute value. I'm going to make a very little revision about the absolute value. If we have x less than or equal a, that produce notations that will produce that x should fall between minus a and a, or I can say that x belongs to the closed interval a. If x less than or equal less than without equal a, I will get the same thing but without inequality, without equality, or I can get that x belongs to the open interval minus a and a. And if I get, this is the type where the absolute value is less than the constant. I'm going to take the other case, which is here. If the absolute value greater than or equal some constant, the result will be x greater than a or x less than minus a, okay, with equality here. And the same thing with the same expression. Same expression. And, oh yeah, that's it. I'm done. So we have this case in this example. We have this case which is an absolute value greater than or equal to 3 and a constant, which is 3 divided by 2. So I'm going to have two cases. Either case 1, either x minus 3 divided by 2 greater than or equal to 3 by 2, which is take the same expression and make it greater than or equal the constant, and the result will be, I'm going to rewrite it here, up there. And 2. And x, I'm going to move this to the other side, so I can get 3 on 2 plus 3 divided by 2, so x should be greater than half of 3 plus half of 3 should be 3. So this is the construction number 1. Okay, I'm going to erase all these in case you want to write it. Just please pause and record it in your notes. If somebody writes his notes in Google, in good notes at 5, the program, and has iPad, he can just send his notes to me, so I can just share them and put them in the description, so that the other student could get benefits of them. So this is the first construction, and the other case, or we have either, and now we have or. The other case will be x minus 3 on 2 less than or equal minus 3.2. Okay, so the result will be x less than, and I will move this constant to the other side. The result will be 3 divided by 2, and that will be 0. So x less than or equal 0. This is the next construction. So what I'm going to say right now, I can say that the domain of the function g equals to all the x's in the real line such that x greater than or equal to 3, or I can write it or I can just write it or logical notation, which is or, same thing. It's up to you. Let me stick with the normal or, and x or x less than or equal 0. This is the domain of the function g. Now I'm going to move and find the range of that function, and from our notation that we just studied in the last function, the range will be the range of the function g. It should be all x in the all y's, all g's, because I'm assuming that this is g, or you can say just y. It's just a matter of notation. It has nothing to do with the reality of the name of the function. You can choose just A, you can choose B, as soon as it's a range, so it's a range. It doesn't matter what do you denote the real numbers that belong to the range. So y belongs to the real line such that y greater than or equals 0, because it's a square root, and the result values, or I can say the outputs of this function cannot be negative. It could be 0 and it could be positive, but it cannot be a negative values. So I'm going to graph it for you right now, just to make things consistent. As I told you, you don't have to graph. I emphasize and I repeat, you don't have to graph. I just graph to you just to make things consistent. I have 0 here. Let me change it, make it easier. Going to write, this is the origin, this is x, and this is y, and the domain of the function will be, this is the 0, x equals 0 here, x equals 0, and this is 1, 2, 3, and this is x equals 3. The graph will be such that, see, I can see here there is no any graph, and the domain of the function will start from here. So the input will start from x equal than or equal greater than or equal to 3, and start from here from x less than 0 and goes to the left side, and I can substitute all the positive numbers that are greater than 3 or equal to 3, but I cannot substitute or feed these numbers to the function, because the result will be not well defined, not defined at all. And I can see that all the result will be more greater than or equal to the line y equals 0. You can see that this line is just y equals 0 because no y. So the range will be all the real numbers that equal to y equals 0 or greater than to y equals 0. So I put the range of the function as all the real numbers in the real line, such that these numbers are greater than or equal 0. So see you guys in the next lecture. Thank you.